Cool. Afternoon, everyone. Next up, we have Howard Griffith from University of Texas at Austin, presenting on Jamf API CLI tool, one solution for secure Jamf API access in policies and scripts. At the end, we'll do Q&A, but if you can please put your hand up, I'll pass the mic to you. I'll run over to you guys. So over to you, Howard.
Good afternoon, everybody. So just to kind of level set, or a few expectations to set. This is my very first JNUC presentation, so be gentle, please. What I'm going to be talking about today, right now, is a proof of concept. It's not a production ready, but it could be very quickly. So set that expectation. And then if I start talking too fast, start waving your hands like this. That way I know to slow down, because I tend to talk fast when I'm nervous, which I'm a little nervous right now. Okay. So as our introducer has said, my name is Howard Griffith. I'm a senior systems manager for the University of Texas at Austin. Specifically, the liberal arts instructional technology services. My group takes care of about 3,300 of the 11,000 Macs on campus, just to give you an idea of how many machines I'm playing with. I'm in the Mac admin Slack under Howard G. Mac, so after the presentation, if you want to bombard me with questions, feel free to DM me. If you want to yell at me, that's where you can send it. And so one of my favorite podcasts is the Mac Admins podcast, obviously. And they do kind of a tech origin story, if you will. And so to get over my nerves, I thought I'd give you just a brief tech origin story from me. And I'm probably going to date myself doing this, but bear with me. So my tech origin starts in middle school with a TRS-80 computer. And a couple of years later when my parents bought a Commodore 64. After high school, I enlisted in the Navy and spent the first 2 of my 6 years in the Navy learning how to fix the combat display systems on aircraft carriers. And for those of you going, what the heck does that mean? That's the electronic systems that take the radar signal, figure out where the bad guys are, and if you notice on the movies, they always had the little hieroglyphics of where everything was and how fast it was moving. Yeah, I learned how to fix the equipment that made all of that possible. So right after school, I got assigned to the USS Constellation, which was one of the last non-nuclear aircraft carriers in the U.S. Navy. And the weird thing about being on a ship and being in the Navy is sometimes you get sent to do other things, and they call that temporary assigned duty. So as soon as I got to the ship, they sent me TAD to the ship's library, which at the time was still not electronic. All of their manuals, repair manuals for all their stuff, were still paperback. So as you can imagine, that was kind of a challenge. So I'm actually gonna skip forward because I think so if we fast forward a few years later to about 2000, I got a job with Microsoft Technical Support doing home productivity software support. So if you remember Microsoft Works or Microsoft Picture It, I started out in that team, and shortly after I got there, they said, hey, you know Mac stuff. So they sent me over to what was Microsoft Office for Mac OS X. And so I stayed with that team for probably 3 years. Started out as just a regular support guy, got really good at it, and moved my way up to an escalation engineer, which basically means that's the, short of talking to the Microsoft developers, I was the last person you would talk to about a problem with Microsoft Office. Their support contract with the company that I worked for ended in about 2003, but Microsoft called me back a little later in probably late 2004 because they were switching providers again and asked me to do kind of backup as they transitioned from one team to another. So I actually got to go to Redmond and take phone calls again for a little while they did that. So in early 2008, I joined Eastern Washington University, and I started out as an IT tech, running around, fixing problems for faculty and staff. I moved my way up there to the help desk supervisor, and then jumped sideways, maybe, I guess, over to desktop engineering. And so I was the one person at Eastern Washington University that did the desktop engineering for Mac and Windows. I had 1,000 Macs and about 3,000 Windows machines using SCCM on the Windows side, and started out as Casper Suite and then became Jamf Pro on the Mac side. In late 2021, I got to join the University of Texas at Austin, and that's where I've been since. But that's not what we're here to talk about today. See there, I was not clicking like I was supposed to be. And so what we're here to talk about today is the API token tool is a command line utility that, when called, provides an API bearer token key and its expiration information without exposing the sensitive credentials on the device it was called from. And so on our agenda today is going to be an overview or how the API token tool works and why to use it, an overview of the security model, setting up and building it, how it can simplify our scripts, and handling any potential misuse, and then Q&A at the end. So, when invoked, the tool sends the signing information of the tool and the serial number of the machine it was running on to an initializing webhook. If the sent values are verified, the initializing webhook returns an address to the authorizing webhook. And the tool then sends the client token key from the device to the authorization webhook. And I am totally messing this up. If the client token key is verified, the authorization webhook returns the appropriate API bearer token and its expiration information. I'll clarify that in just a second. So, and then if either of the webhooks rejects any of the values represented, it returns basically a 401 unauthorized error message. The tool caller can then use the bearer token information to make appropriate API calls to the Jamf server based on the permission level of the token key. The tool can be used in a script to refresh the bearer token information if the expiration period of the initial bearer token is reached. And the API token tool negates the need for embedding or the obfuscated API credential information directly in the script or sent as a script parameter in a Jamf policy. When set up properly, it can provide different levels of API access based on the client token key used, and again, without exposing the underlying credential information for those. So the security model. The tool must be signed by the organizationally recognized signing certificates. The tool signature should indicate that it hasn't been altered, and the tool must be run from a device that is enrolled in your Jamf instance. Because we don't want somebody to get obviously the binary and be able to run it on a machine that isn't under your management, because that would defeat the security. The second layer of security is the tool must present a valid client token key, which I'll discuss in just a minute. The authorization webhook will authenticate that, and the authenticated client token key is what determines the API access permissions. So the client token key that the computer has is just a really simple time-based UUID. You generate them when you set this up, and they're pretty hard to figure out for the most part, which is why I selected this as a key to use. The authenticated client token takes the first one and applies a namespace DNS to it and effectively changes it, but that gives you a way to verify that the token is yours. And as far as in my testing, I didn't find any way to cheat that. If you find a way or you know a way, please let me know if I'm going down the wrong path here. So these are just an example of client token keys. As you can see, they're just UUIDs. And then the corresponding authenticated ones. And in this case, or for my example, I've got 3 different access levels. One is a read-only computer, a read and update only, and then for your desktop engineering folks, one that can read, update, and or delete computer objects. However you want to structure the permission level, once you've set up the account in Jamf, the idea is that you have a separate key for each level of access. That way you know what the machine is allowed to do. The token key in this case would be delivered to the computer that you're running it on via a configuration profile. So when we're setting up and building this, the configuration profile identifier for the client token key, you'll want to decide on that. How many API levels of access are needed, determining which Apple developer signing certificate you're going to be using, and the hosting location for your API token tool webhook responders. In my proof of concept, I used AWS Lambda, but there's no reason that this couldn't be adopted to like a Docker instance if you wanted to use that. Or basically anything that can host a webhook, you should be able to do it. Preliminary API took the steps. So you're going to generate and document your client token keys, upload and configure the API token tool webhook responders, and then document your webhook responder URLs. On the Jamf server side, you're going to create configuration profiles for each of your client tokens. You're going to set up appropriate API user accounts with the proper permissions and create necessary transition scripts and policies for your existing scripts and policies that already make Jamf API calls. On the intermediate API token tool steps, you're going to set the initial webhook responder URL and the configuration profile identifier in the binary source. You're going to build and sign that. You're then going to set the signing information, server, or the Jamf server URL, your API read-only access credentials, and the authorization webhook URL in the initial webhook responder. So the initial webhook responder is the one that's going to be verifying that the machine runs or is managed by you. So it needs at least read-level access to your API. We're going to set the authenticated token key values, our Jamf server URL, and the corresponding API credentials in the authorization webhook responder. We're going to deploy the API token tool package to appropriate test devices, assign a client token configuration profile to the appropriate test devices, and then you're going to test all of your new scripts and policies that use the tool for your API calls. And then our final steps would be to open terminal on a test device and use the API token tool binary to verify that it actually presents you with the API bearer token. On the Jamf server side, you're going to roll out the changes to your scripts and policies that actually use the new tool. You're going to deploy the API token tool package to all the appropriate devices that you want to use it on, and assign the client token key configuration profile based on the level of access that you want for all of your machines. So how this can simplify our scripts, as you look at this, you can see most of the scripts do some kind of obfuscation of the client credentials, or they get it as a they get it from the policy as a what is that word I'm looking for? As a variable. And so this is just a simple screen shot that shows you that with the binary, you can just call it, and it takes care of the authentication to Jamf to get the appropriate token, and you just roll on from there to make your API calls. So handling potential misuse, single device compromises, like if you have a computer that's talking more than it being a little chatty, you can unscope the client key from that machine, at which point it won't be able to talk to the webhook anymore, and it'll stop. Single API permission level compromise. You can change the client token key on the authorization webhook responder. And then multiple API permission level compromise. You can change the authorization webhook URL in the initial webhook responder so that it can't get to that second level and give you tokens. And so this is the GitHub site where I will be setting up all of the source code for this. Some of it is already up there. By the end of the week, I hope to have the rest of it up, along with some really basic instructions on how to set it up if you're using AWS and get it going for you. Like I said, this is a proof of concept kind of tool. So my initial binary on the Mac is actually a script file. My hope is to eventually make it Swift. And thank you, everybody, for listening to me drone on. Questions?
So my question is, why even retrieve the token or the access, and why not just make the webhook do the API call to Jamf instead? So that way, in the webhook, you could very much limit what you can do instead of giving a full API key where you can change maybe all smart groups. You can instead, the webhook could only touch one smart group, etc. Just security. Instead of you having to get the key, you just do it directly. Does it make sense? Sorry.
So try asking me that one more time. I think I got it, but
yeah. So if an example, I had a script where I wanted to put someone in a static group, like because something happened. And instead of me having to get the API key and then do the call to Jamf, like in the script, why not have the webhook just do it for me? You authenticate to the webhook, and the webhook calls Jamf and does whatever I do instead of having to, expose the API key to my machine, and it can.
Okay, so I think I understood your question, and let me answer it this way. And if that doesn't answer your question, then we'll try this again. The way that I have this set up, or at least the way I thought about getting it set up, was if you're calling the tool. The tool calls to the initial webhook with its serial number and the signing information from the binary. And that's mainly a security feature to make sure, number one, the tool belongs to you. And like I said in my presentation, number two, you want to make sure that you're calling it on a managed machine. Now, in my experience, most of the machines that we typically run scripts on, you either want to be able to read something in the API, or you want an automated way to update something in Jamf for that particular machine. Like, let's use an asset tag or some kind of EA. So in that case, it's super easy to set up a client key that has read and write access to the computer model itself, and only that access, so that if somebody that knows that you're using that has to be on a machine with that privilege level in order to use it. So they're not going to be able to delete computers using it, obviously. So the CLI tool, once it authenticates that yes, it's allowed to talk, it uses that token key as the gateway to which API access level it has. And then the authorization webhook is the one that actually gives it the correct Jamf API bearer token information. And then your script, presumably from there, can run with that information and do whatever it needs to do with the Jamf server. And none of the API username and password information ever gets seen on the client computer. It's not not obfuscated in the script, and it's not a parameter coming from a Jamf policy that you could see either. I hope that answers your question.
Yeah, that's fine.
So what are your applications for this day to day?
I'm sorry?
What are your day-to-day applications for this? The use cases.
My use cases, I kind of left it, open-ended. If you're running scripts on on your computer as a desktop engineer, and you have multiple levels of, I guess, like in our case at UT, we don't have a centralized IT team. And so various departments have their IT representatives, and this is a way that we can focus them or only give them access to a specific subset of machines. And again, you don't run the risk of somebody like running a script that would delete computers on a machine that isn't appropriate to do that from. So really, anything that you can think of as far as doing stuff from the API, you can kind of mix and match your security levels depending on what you need to do. Does that answer? Well, thank you everybody for your time. Like I said when we started, I'm on the Mac admin Slack under Howard G. Mac. Feel free to ask me questions there or shoot me daggers there, or and I really appreciate everybody's time today.